Yeah, hi guys, welcome to the present video. So in this video, we are going to see the previous year questions of the IES and the GATE, and you may check down the circuits on this on the screen. And so please share this video as well as this YouTube channel link to the graduates as well as the postgraduates who are preparing for the electronics related the competitive examination. So it will be very much helpful to them, guys. Okay. So now we will enter into the video. So first we are going to see this circuit, guys. So it is the first one, and it is the IES 2021. That means the previous year question it is. So you just check out the question once. In the figure given below, the value of the voltage drop across the resistance R1. That means in this resistance R1, they are asking to find out the voltage drop. So first of all of you observe, may I draw this circuit as like this? Whatever the circuit they given, may draw this circuit as like this. So here 40 volts it is, and 50 ohms, 200 ohms, and 100 ohms, as well as 300 ohms it is. Got it? That means I just straighten this one and this one, both these two. Okay, I took like this. Now they are asking to find out the value of the voltage drop across this one. Now if I redraw this circuit as like this, from here to here the voltage will be 40 volts, and from here to here also the voltage is 40 volts, correct? So now if I apply the voltage division rule, okay, with the help of the voltage division rule, the voltage drop across this 100 ohms can be taken as a voltage drop across the 100 ohms can be taken as that resistance divided by total series resistance, that is 100 plus 300, into the total voltage across this branch. How much the total voltage is there? 40 volts is. So that is equal to 1 divided by 4 into 40, that is equal to 10 volts. That means the voltage drop across this 100 ohms can be taken as a 10 volts. So here option B can be taken as a correct answer. So to work out this question, you should know about the voltage division rule. Okay, you should know about the voltage division rule. So if any one resistance is like this, and let's take it is R2 and it is the R1 and it is the E. Now if you want to calculate the voltage drop across this R1, that is VR1 is equal to that resistance divided by total series resistance, that is R1 plus R2 into total voltage what we connected. Okay, into E we will take. Okay, so it is a way of solving this question. So let's go to the next question. Yeah, this one. It is a GATE 2021 question, guys. Okay. So in this question, you can able to solve out. I mean, first of all, have a look here what they are asking to find out. So consider the circuit with an ideal op amp shown in the figure. So assuming the V in, that means this input voltage is less than the VCC, and V reference is also less than the VCC. Then what, and your if V out equal to 0, that means if this V out is equal to 0, what is the relation between the input voltage and the reference voltage? That's what the options are given here. Okay, so come on guys, let's have a look how to work out this one. It is the ideal op amp as they already given. So if any one op amp is tell to be a ideal op amp, then it follows the it follows the virtual ground concept. And I will tell you what is this virtual ground concept. I mean, in the previous video also I told about the virtual ground concept. Okay, so virtual ground concept means whatever the inverting voltage terminal voltage is there, the same voltage will also be maintained at the non-inverting terminal. Okay, that means whatever the non-inverting terminal voltage is there, the same voltage will be maintained at the inverting terminal also. Why it is happening like this? See, I will explain this point also. If any one op amp is tell to be an ideal op amp, then what about its gain? Its gain is equal to infinity, right? Ideal op amp gain is equal to infinity. Now, so for any one op amp, if I took the op amp as like this, it is the V0. Let's take it is minus and plus. That means it is the inverting voltage and it is a non-inverting voltage. Now and if the gain of this op amp is A, then V0 is equal to A into non-inverting voltage minus inverting voltage. We will take as like this. Why? Because it is a differential amplifier will be there. Now from this one, we can also write like this. Gain is equal to V0 divided by non-inverting voltage minus inverting voltage. As I already told that for the ideal operational amplifier, the gain is infinity. That means if this A has to be infinity, definitely the denominator part has to be 0. That means if I equate the denominator part to 0, that is Vn minus Va is equal to 0, then non-inverting voltage and inverting voltage, both these two are same. That's how the virtual ground concept is applicable in the case of the ideal op amp. So now here the non-inverting terminal, it is connected to ground. That means the 0 volts will be there. And similarly here also the 0 volts will be there. Okay. Now let's take some current I is coming here, and here I told that here the 0 volts means here also the 0 volts will be there, and this I is dividing into the two parts, and here I1 and let's take like this. Yeah, okay. So I is equal to I1, right? Why? Because here also 0 and here also 0 means there is no potential difference. If there is no potential difference means you can't able to take any some current here. So here is a 0 current you can take. If it is a 0 current means then what will happen? Whatever the I is flowing here, the same I is equal to I1. Got it? I is equal to I1. Why? Because in this direction no current. And in this direction also no current. Why? Because the ideal op amp input impedance is infinity. So here also 0 amperes will flow. And let's take it as a feedback resistance. Some IF amount of current is flowing through the feedback resistance. Okay. So now as per this concept, now we can see that. Okay, just carefully have a look here. I'm just erasing this one, guys, so because I need some space to solve. So I'm erasing this one. So if you want to just make a note of all these points carefully. Okay. Okay. Now, so I can write that I is equal to I1. I is equal to I1. Okay. And I can be taken as a starting voltage. What is the starting voltage? V in minus ending voltage is 0, right? V in minus 0. And what is the resistance in between both these two starting and ending voltage? R. That is equal to, and next what we can write? Just a minute, guys. So I1 is nothing but current flowing through like this. So the starting voltage is 0 minus of, what is ending voltage here? Minus V reference. Minus V reference divided by R resistance. That means this one also R and this one also R. Now if I cancel both these two, now what I will get? Vin is equal to V reference. All of you understood? I got the Vin is equal to V reference by cancelling both these two. Fine. Okay. Now whatever the I is there here, I told the IF, right? So IF is equal to what I will get? Starting voltage is 0, ending voltage is V out. So 0 minus V out divided by RF. And from this one, we can write that minus V out is equal to IF into RF. So as per the given question, if V out is equal to 0 means, so V out is equal to 0 means current also becomes is equal to 0, right? That means here also 0 and here also 0, there is no potential difference, and current flowing through this one also becomes is equal to 0. Okay, so by looking all these conditions, we can tell that I is equal to I1, then this condition got satisfied, that is Vin is equal to V reference, and out of all these options we can take option A as a correct answer. All of you understood? So it is a way of solving this question. Fine. And now while coming to this question, so I will give some clue here. So with the help of that clue, please try to solve this question. Otherwise, I will tell you in the next video. Okay. So what is the value of maximum power transfer to the load resistor in the given circuit? So it is RL is given here. That means maximum power delivered to the load. So actually, as per the maximum power transfer theorem, maximum power delivered to the load expression can be taken as Vmax is equal to Vth square divided by 4 into RL. So it is the formula. Okay, and one more concept also I will tell you, that if you take any some circuit as like this, it is the voltage and it is a source resistance. Okay, and if you connect some load resistance here, got it? So if you take some load resistance here, then if the maximum power has to be delivered to this load resistance, then source resistance and the load resistance, both these two has to be same. Okay, so now whatever this part is there, apart from the RL, I am converting this entire part into one voltage source and one resistance, which is nothing but a VTH and RTH, and then I will connect this load here, nothing but a RL. Now RTH and RL, if both these two are equal, then only the maximum power will be delivered. Fine. So what you need to calculate in this part is that you have to find out the Thevenin's resistance, which will equal to RL, and you should also find out the Thevenin's voltage, which is nothing but VAB. Okay, so after calculating of both these two, then you have to substitute here. Then after substituting, you will get the maximum power delivered to the load. Got it? Okay, so try to find out this one. Thevenin's resistance as well as the Thevenin's voltage. Okay, so whatever the answer out of the ABCD, whatever the answer you are getting, so please post your answer in the comment section. Okay guys, so I hope that you understood some of the points from this video. Okay, so apart from these questions, whatever the examination you guys are preparing for the further any some type of competitive examinations, if you are preparing for, so please share the previous year question papers PDF link in the description box of the, in the comment section of this video. So based upon that link, I will try to solve those previous year questions as per your examination point of view. Okay, so thank you very much guys, and all the best to the candidates who are preparing for the competitive examinations. So we will meet in the next video.